So this will be my last talk as an engineer. I have to go become a nanotechnologist now. It's very sad. So I'm Rachel Myers. This is a star monkey. If anyone was a Wise Poignant Guide fan, that was my first book, so I self-identify as a star monkey. If I've met so many people here, if I haven't met you yet, please come talk to me. I brought a whole bunch of stickers. I'm trying to give them all out. So if you're a woman, I brought like the woman coder cat stickers from GitHub. You should totally come get one. If you're not a woman, you can have these too, or I brought a whole bunch of other ones. And I also brought stickers for one of my volunteer projects called Railsbridge. So Railsbridge holds workshops for women and other marginalized groups, and we teach people to code. So we have a lot of open source curricula that we maintain, and anyone is welcome to use that for any kind of workshop that you want to put on. We're also really cool because we're making the world a more diverse and more tolerant community. I said the world, but like technology more diverse. So come talk to me if you want to get involved with Railsbridge or if you just want a sticker to kind of show your support. As I mentioned, I brought a lot of GitHub stickers. I've been at GitHub for about a year now. I do Rails and CoffeeScript there. And my work focuses mostly on an app that's used behind the scenes. So if you want a new button, I'm not the person that you should talk to. So before I worked at GitHub, I was a developer at an e-commerce company called Modcloth. I worked there for 2.5 years. And I mentioned that because Modcloth, in the first place, I got to start digging into performance optimizations. So some of my stories start there. It was the first place I got to like kind of get my hands dirty. The last thing that I should mention is that all of my references are available in this bit.ly bundle, bit.ly/standback. You might recognize that as a XKCD reference. Anyway, so I initially proposed this talk called Improve Web Performance Without Breaking Metrics. I found that with the current browser standards and the current third-party tooling, doing things that are good for web performance sometimes make it harder to measure performance. That's counterintuitive, and it's downright terrifying if you're the kind of person that wants to measure the impact of your performance optimizations. So that content that I originally had in mind is still the heart of this talk, but as I've worked with the topic for a little bit longer, I started to see some larger patterns. I saw some times when teams that I had been on, or maybe I personally, had tried to make performance optimizations, and I ended up harming either performance or the ability to monitor performance. So this talk is now a broader exploration of how we're not using science and how we might be able to use science to avoid these types of disasters. It's not cool nanoscience, though. So I don't have any ferroliquids. I have no props. It's going to be not quite as smooth as last one. So now I think a better talk title would be Science, Web Performance, and Disaster, because that just sounds cooler. So I'm going to start with a kind of zoomed out view of performance. What's the general landscape? Where have we been? Where is performance going? And so one of the last things that I did at Modcloth was optimizing a large legacy Rails app. Does anyone here do Rails? A few people, it's okay. I understand if you don't want to admit it. So one of the things that was distinctive is that it was a few years ago, so when you could turn off JavaScript and you could still accomplish everything that you wanted to on this app, right? It's kind of a different world. So all of the real action happening on the server, and having all the action happen on the server means that server performance is really important to the stability and the reliability of the app. And something was also true for our database. Database performance is really tricky because what counts as fast enough changes over time. All right, so having everything happen on the server means that stability and reliability can really be monitored from your server. And one of the things that makes database performance especially tricky is that the line for what you have to do is always changing. It's a problem of resource contention. So when you're kind of a small app, you have a limited number of people who are trying to access your resources. As you grow, you have more and more things trying to access those resources. And so that changes. As opposed to like a browser, you have one user trying to access this is so hard. You have one user trying to access their browser, and so you don't have the same resource contention problem on the client. So that meant that we could get a pretty accurate view of how our app was performing in the real world for real users using off-the-shelf tools that provide real user monitoring. Real user monitoring, sometimes called RUM. So we were using New Relic, for example, and we were getting data that was fairly representative of how our app felt for real users, which all is to say that a few years ago, we were doing two different things when we were considering performance. We were trying to get a sense of how reliable and stable our system was. We were trying to plan for the future a little bit. And we were also trying to make sure that the site was fast enough for users to have a really good experience. So we had these two different motivations for measuring performance, and I don't think we realized it at the time. So as we've swung back to a thinner server and a fatter client, those distinctions have become more obvious. We've become two separate performance tribes. We have two separate communities. We're both obsessed with performance, but we're coming from two really different perspectives. So I have an analogy and a cool picture. As an analogy to keep in the back of your head through this talk, as I try to pull apart these two different performance tribes, think of a race car. The differences in the performance community are similar to the different skills you need for a race car team to win a race. There are engineers who concentrate on making sure the servers are fast and reliable and that the databases aren't overloaded. And those are a lot like the people who, during like an F1 race, are concentrated on maintaining the engine or switching the tires really quickly. These are like the mechanics, and they have expertise that's focused on the car itself. There's usually one specific part of the car that they're focused on. They all probably know how to drive a car, but you don't send them out to drive a car during a race. And then there's another set of engineers. They're the people who concentrate on web performance, and they're a little bit like race car drivers. They're the kind of people who understand that they kind of understand that there's a motor, there's some tires, I get that. But during a race, they're aware of strategy. They're trying to keep in mind the whole dynamics. They want to try to keep the limits of the car in mind and also try to situate it in overall context. To win a race, we need both of these skill sets. But these two groups are doing really different things, and they have to work together. So the mechanics are great, making sure the car runs. In the hands of a mediocre driver, the fastest car is not going to win the race. So it's like a website that's been optimized for scalability and reliability, but has never been optimized for users. Here's what I actually mean without metaphors. Here's a waterfall chart of a page load from page load test. This is GitHub. So it's already been hella optimized. Even so, this is the part of performance that the mechanics are controlling. This is the part that the drivers are trying to optimize. I know that's a really controversial graph to throw up, and we can come back to that. But right now, it's just important to remember that there are these two different approaches. One's about maintaining a reliable backend, the other's about making it available to users. I think that right now, a lot of people are concentrating on this little sliver at the front, and so you have an experience that's bad for users. Spending your time in the slow lane. I'm just going to talk shit. It's fine. So that's a little bit of a performance overview. So let's take a look at server performance. All the stories that I'm going to tell are kind of like war stories / ways that Rachel fucked up. War stories sounds way better. War stories. Okay, so in 2007, so I'm a Rubyist. In 2007, a Japanese professor named Koichi Sasada pushed up a rewrite of Ruby that was focused on performance. A little bit about the Ruby community. If you really love Ruby, you show that by rewriting Ruby. It's a thing. So he has a sense of humor about this. He called his branch Yarb, yet another Ruby VM. He had a sense of humor. And Yarb was focused on performance. A side note, I've often heard people say that if you need performance, you shouldn't be using Ruby. I would say it's not that simple. So there are some engineering problems where all you really need, it's very clear that you're just optimizing for performance. And in those cases, Ruby is probably unnecessary overhead for you. And garbage collection can be really fun in some of those situations. But what's more common in my day-to-day is that I want to balance a few different concerns. For instance, every day I need to balance code terseness with code readability. For what it's worth, I usually skew towards readability. The same kind of thing is true when choosing a language for a particular system or service. So I usually need to optimize between two axes. So I need to optimize for machine speed, but also the speed of the people who are writing. Ah, wait, I went the wrong way. Yeah. Animations, you guys. OK, all of which is to say, Rubies care about performance. We just care about other things, too. So back to Yarv. At the end of 2007, Matt, the creator of Ruby, finished fully merging Yarv into Trunk. So it was created at the beginning of 2007, took a whole year. It's fine. It was released as Ruby 1.9. And it was all over the conference circuit. You have to upgrade to 1.9. So we would go conferences, we would hear about the performance benefits, people would benchmark it. There was one really famous benchmark that said, it cut down the time spent in my Ruby layer by 1/4. That's dramatic. So I like young Rubyist, right, wanted to upgrade to 1.9 because it was faster. That means it's better. You laugh, like my logic is flawed. I do not understand. Anyway. But I didn't have much much real world data to say how it would affect the performance of my app that I was maintaining. And I also wanted to upgrade because the person who would run the upgrade was something of my mentor. So I was pushing for this. Felt very invested. So it was a quick upgrade. It took about a month, which in the land of Ruby upgrades is fast. And we watched, and so we deployed that branch to production. We sat and we did this and watched our performance graphs. And the Ruby layer got slower, not faster. So we ended up merging it. It didn't get that much slower, so we just decided to accept the cost. But I was really, really upset about this. So I dug in and tried to figure out what was going on here. It turns out that our app was too clever. Ruby makes metaprogramming really easy. Some would say it encourages bad habits of metaprogramming. And we were definitely taking advantage of that. So all of our metaprogramming ended up costing us performance when we moved it to Ruby 1.9. Here's how that happens. So method lookups in Ruby are expensive. When a method is invoked, like down here where Codemania Racecar is going to cut somebody off, it needs to check the class where that's being invoked. It needs to go up the class hierarchy. It needs to look in any included modules. So that's a lot of looking. Ruby 1.9 tried to improve that by implementing a Ruby method cache. When a method gets invoked, it checks to see if it's looked up that method before. If it has, and the cache is still valid, it will go directly to that cached version. This is like the bytecode assembler. It's not important. Just like check out where it has the inline cache and a generation next to it. So here, we're using some metaprogramming to define a method. So when we use metaprogramming, like define method or method missing or any of these things that if you talk to Rubyists are like, this is why Ruby's so cool. On one hand, yes. On the other hand, this is what happens. So now that we're using define method, we're going to still have to hit the method cache, and that method cache isn't going to be useful to us anymore. Using metaprogramming is going to increment our inline method cache. So instead of being a time saver, the method cache becomes one more thing that we have to do in the Ruby layer. And since those values are now constantly being invalidated, we don't get the benefit of that. So here's the bytecode. After we hit define method, we update our generational method cache, and it becomes slower. Everyone had this problem. So in generational method cache. So in Ruby 1.9, it was a generational method cache, meaning that events like define method would invalidate the entire cache. But everyone had this problem. Everyone was grumpy about this problem. So before Ruby 2 was released, they introduced a more incremental method invalidation, method cache invalidation. So if you're on the latest Ruby, you can metaprogram a little more freely, but you probably still shouldn't do it that much. As a side note about how we handle these at GitHub, it's really different. So Ruby and Rails have been internally forked, and so we maintain those. We do one good thing, which is instead of merging our upgrades without a good idea of the performance costs, imagine like the costs. Like when I was at an e-commerce company, like we could deploy on a slow day and it wouldn't be that bad. If we were to deploy something at GitHub with a performance impact, that would be a much larger impact. So it gets tested for a long time before it hits. But because it's also a fork, it's a different type of anti-pattern. It means that improvements to the language or the framework all have to be backported. So anti-patterns everywhere, you guys. So at the time of the Modcloth Ruby upgrade, the engineering team was mostly dudes, and then it was me. And this was a site that sold mostly dresses. This is Modcloth. So I was probably the only engineer that was using the site on a regular basis. And as someone who's actually using the website, I was really frustrated when the site took a long time to load, or when it would load the header first, but what I really wanted to see was an image of the damn dress, right? So I had hoped that the Ruby 1.9 upgrade would make everything faster. A few months later, I learned that even if the Ruby upgrade had helped the Ruby layer, it probably wouldn't have helped me as a user. I learned that server performance is not the entire story. I learned about the performance golden rule, first described by Steve Sodders. He was the lead performance engineer at Google, and he's moved since then. He recently became the chief performance officer at Fastly. And the link to the article where he describes the performance golden rule is in the bit.ly bundle. So the performance golden rule is 80 to 90% of the end user response time is spent on the front end. Start there. I know the performance golden rule is going to be controversial and surprising to people. It's surprisingly surprising to people. It's been around for a long time. And I know a lot of people will be skeptical. But I have some good news here. It's not something we have to leave up to our suspicions or our biases. We can measure this. So if you're skeptical, pull up a website. In Chrome's developer tools, you can view different breakdowns of the page load in the navigation or the timing tabs. You can also go to webpagetest.org, give a URL, and you can test it in a lot of different situations. You can select different locations, network connections, user agents, and you can see how your page is performing under all those different conditions. Remember, it's still only a synthetic test. It's not like real user monitoring. Okay, so to describe my revelation of web performance, as opposed to just server and database performance in terms of my race car metaphor, I previously thought the only way to win a race was to be always mechanicking, right? It never occurred to me that there was a separate skill in driving the race car. So, of course, as soon as I found this out, I wanted to learn to drive a race car. So I got interested in web performance, and I started to see these blogs and presentations happening from large companies. Google, Amazon, eBay, there were other people, and they were doing web performance experiments. The experiments were kind of amazing. They were pretty gutsy. So they'd take an experiment group of users, and they would impose an artificial delay for the page load of that group. Then they would measure how that changed their behavior. So links to all those studies are included in the bit.ly bundle if you want the nitty-gritty details. Here I'm just going to summarize. They found that increases in page load time decreased the number of page views. They decreased user interactions on the site. For sites that had things that you could buy, they decreased conversion. That's like the business word for buying shit. Maybe everyone knows that. Okay. They also increased the bounce rate, the number of people that would just come to the site and immediately leave without doing anything. So eventually, we, like me and then a few other people, convinced the business types, the people who measure their own personal success in life by things like conversion and page views, and who also set the direction for engineering, that we should start taking performance seriously. So the motivation behind web performance as a field is that we want to improve performance as the user experiences it. And so one thing that makes this harder now than it used to be is that a lot of people are experiencing the site on different devices. And each of those need their own approach, and they have really different performance profiles. So it's hard. So I was involved in optimizing for the phone. We knew that the networks that a phone is connecting to could be much more of a bottleneck. So we had to reduce the number of overall HTTP requests. Every time I have to say the word HTTP into a microphone, it's a disaster. That went really well. Okay. So we would concatenate our JS, we'd sprite our images, all the like normal things that you're supposed to do. But we also knew that we needed to cut the bulk of those assets and images and CSS and HTML down as much as we could, because you have a really underpowered device that's trying to interpret all this stuff. Next, please. There we go. Okay. For people who are coming from a real computer, we had to support more diverse browsers, so that's more extra code. But we found that we were going to be kind of aggressive in dropping support for specific browsers. We set an arbitrary line. We said, if this browser is less than 1% of our traffic, we're not supporting it anymore. And we used different analysis tools to find the code that we could delete after we stopped supporting those browsers, which felt really good. We also had to get smarter about how we were making our asynchronous request. So the most important thing there was to untangle how we were loading third-party scripts, how we were requiring our own scripts. We didn't have ads on our site, but I know that add JavaScript is incredibly, just notoriously terrible. So if you can like pull that out and load that asynchronously, that's awesome. We had at one point something like 30 tracking pixels, and that was our version of this problem. So everyone who has referred you to a page wants to have a tracking pixel so they can like charge you some cents for that referral, and they want a pixel on every single page, and they want it to be the first thing that loads, and you have to be really strong with them. No. So so one thing that we should have done, but it occurred to us later, was that when we started pulling out code that was more temporary than other files, things like browser shims and polyfills, we were going through all this hard work of figuring out when that code should load, under what circumstances, and in retrospect, the thing to have done would have been to find a way to enforce a sunset on that code. So sunsets, expiration dates on codes. Emily Nakashima, she was a person I worked with at Modcloth, and now I work with, again, at GitHub. We've been talking a lot about how to maintain a front end, and sunsetting code is one of the best ways to keep your code maintainable. So there are links in the bit.ly bundle to what we're trying right now. The great thing about it is that as you're going through your code and you're thinking really hard about when this code needs to load, that's the only time you should have to do that, right? Document it somewhere and not just in comments in a failing test so that you don't have to go back and figure that out in a year. So the most important thing to keep in mind for the people who are coming from computers is that the people who are optimizing for computers were living by New Relic. So it's a great way to see what pages were getting the most hits and were slow, because that's the place to start optimizing. So yay, New Relic. And then there was the tablet. That was the thing that I worked on for a long time. Tablets usually have a pretty good network connection, but the desktop site on a tablet is a really terrible experience. We wouldn't need to support as many browsers, so there was a lot of desktop-specific code that we didn't want to load on the tablet. And tablets are relatively underpowered, so what takes a short amount of time on a computer can take a lot longer on a tablet. We also didn't like showing people a white page when we got first byte back. So if you click something, your page turns white, and you just sit there and stare at a white screen until your whole page is ready. We didn't want to do that. We wanted to let people keep browsing while we were loading stuff. So we wanted to create a brand new experience. We didn't want to rewrite all of our existing domain logic. Oh, I need to keep doing these bullets. Okay. So to avoid rewriting all of the existing domain logic, we started using the existing Rails app that was powering the desktop as our backend API. And on top of that, we built a backbone app that would be the tablet-specific experience. This term did not exist then, but we now know that what we were doing is called designing for performance. So there was a talk last month, and there's an upcoming O'Reilly book from a fantastic senior engineer at Etsy named Laura Swanson called Designing for Performance. And Etsy is doing really great work in this area. They have this amazing team of engineers, and they have some hard limits on what they can do for performance. As an illustration of that, so like GitHub avoided loading images by creating an icon font, right? So you load the font, it gets cached, you don't have to load all those images anymore. Etsy's always going to have images, so they're going to try a lot of different things, and they're doing a fantastic job. So the idea of designing for performance is to think about performance as the first design principle, to keep in mind that the ultimate goal of whatever you're creating is to make the users happy. It means that you cut features or implementations that are slow. You can't have things there just for the sake of being pretty. My favorite quote from Laura's talk last month is this: "What business metric is this image carousel supposed to affect?" Ouch, right? So the point is, if it's slowing down your site and it's not moving any needles, it's better to pull that out, no matter how great it looks. I love it so much. So we built this tablet experience, and we were trying to do these things. We didn't have these like words for it. That's what we were trying to do. So here's some of the technical details of how we built the site. We created simple templates and routing. All of that was done in Backbone, and it was really lightweight. For pages that were outside the normal shopping flow, we would fall back to the desktop site, things like the shipping FAQ. We cached all of the JavaScript for the normal pages in local storage on the device on the first request. When you click to visit the next page in the site, we would throw up spinners, so you would get some feedback, but we'd let you keep browsing the site until we got the 2 or 3 most important parts of the API back. We'd repaint the page with those important parts, and we put placeholders for everything else. So you could, and then that content would like slowly come in as those APIs came back. So just as a side note, I think it's really important that your placeholders be the exact same size as the content that will come back, because otherwise, your API comes back, you get your content, and it will reflow your whole page. I'm about to click something, and everything moved, and I clicked the wrong address, and I'm angry. Just side note. So, remember that Ruby 1.9 upgrade? It was supposed to make things faster, but it made things slower. We wanted to do this release differently. For one, we decided to A/B test the new site. So we started by deploying it to 10% of the tablet visitors. Sounds smart, right? Hold on. Unfortunately, all of our A/B testing was done with a third-party tool. And a few hours into the test, okay, side note, you're not supposed to look at your A/B test a few hours into your test, but whatever. People couldn't help themselves. So a few hours into the test, it was reporting that people were only visiting 2 or 3 pages over the course of hours. That's weird. It was also reporting that people were almost never adding things to their cart. So these are 2 key business metrics that we promised that we would start to make better, and we were making them worse. Weird. The other thing that happened was that the team that was working on web performance for the desktop was relying really heavily on New Relic to measure their own success. And when we launched the tablet app, they started to see a lot of noise, things that couldn't possibly be true. So they were at a place where the desktop app was loading in about 5 seconds, and suddenly they're seeing outliers all over the place. It would load at 1 second and 12 seconds right after each other. So that team is usually pretty cool. I'm friends with them. They hated me that day. So we get these weird A/B test results. We don't wait for the test to complete. And our business people start to get worried. They measure their own success in life by these numbers, and their numbers are coming back pretty bad. So we knew that the site wasn't really that slow. It was not taking 12 seconds to load. People had to be visiting this page. They had to be adding things to their cart. We could pull up the site on our tablets. We could go to a coffee shop with terrible Wi-Fi, and we could click around, and it was incredibly fast. It felt so fast. So what was going on? Why were our numbers so different than what felt qualitatively true? To understand requires a little bit more context. So until 2010, we were creating apps where everything happened on the server. So we would make a request, the server would do its thing, it would query the database, get whatever it needed, stitch together some HTML. And then it would pass back a response that included a lot of stuff, usually more HTML than you strictly needed. Think about all those modal windows that someone might click to on a page, but rarely do. So they're usually just sitting there set to display none. And then in 2010, something else happened. We also got navigation timing. First just in Chrome, and now it's supported by every browser except Safari and mobile Safari, so shout out to Safari. The navigation timing API gives us much more granular insight into what's happening in our page load timing. We can see what exactly is taking the most time, or when the page is just waiting on something that's blocking. And all of that's available in the window performance object. So if you want to start firing that information off to wherever you keep your metrics, then you can get some more detailed RUM data. If you're already using Google Analytics, the navigation timing is collected automatically. So the thing to note about this is that it's all built on time to window load. Here's a short history of navigation timing. Since it was proposed as a spec and accepted as a standard, it's really quickly gained traction. It's almost everywhere. At the same time, it's a very similar timeline here, we have JavaScript frameworks. So they're really coming into their own at around the same time, and this is because browsers are becoming more and more capable, and client-heavy apps are a way of controlling the details of the experience in a way that you can't do on a server-based app. So the other thing about JavaScript frameworks is that they're making the time to window load almost irrelevant, just at the time that we're establishing all of our timing metrics based on window load. It was tragic. So when we came along in 2013 and created our tablet app, the request response cycle looked something like this. Window load fired when we got back our first response, but as the user would continue to interact with the page, we would continue to make more API requests, get back really small responses. And so this is what it starts to look like. Window load doesn't matter at all. Also, all of the third-party tools are based on time to window load. This is a huge third-party tool fail. They were not aware of what was going on in the world. I tried to tell them that. They didn't care. So we called up our A/B testing people, and we asked them how they were calculating their numbers. We found out that they were built entirely around time to window load, even though they told us that they would support firing custom events to their API. They were doing nothing with those events that we were firing off. Awesome. So the only time they were recording someone as actually visiting a new page was when the user manually refreshed the page. The only time they were recording someone as adding something to their cart was when that person was ready to check out, so manually clicked to go to their shopping cart. Classy. So there was a slightly different story with New Relic. It was also built around time to window load, although I think last month, they launched a new thing to keep better track of your AJAX requests. I don't know that much about it because I'm not using New Relic anymore. That's all I'll say about that. Anyway. So all of this, we had a new problem suddenly. We needed to create some way of measuring our performance with all of our tools failing. So we rolled a Homeworld solution here. I'm going to try to go fast because someone just held up some time for me. You don't have to understand every line of this code. It would be a waste of all your time. And it's really simple. There's a gist. So here's what's going on. For every page that was supported, we put in feature tracking for those 2 or 3 parts of the page that we thought were really important. This is just that thing continued. We're doing a little extra work here to cut out outliers, and then we just push that to Google Analytics. Once we have the timing for each of those features, we can kind of simulate what a page load looks like. So we set up JavaScript promises for those key features on the page. I don't know if anyone has had a chance to play with promises. They're the perfect solution for this problem, though. And then when we route to the new page, we're going to record a start time. So when each of those key features come back, we resolve the promise, we record the end time. And because we were never refreshing the page, we found that a few memory leaks kind of cropped up on us, and we didn't have a really good way to time that either, or to get real user feedback about it. So we also homeworld a little solution to track laggy pages, what some people have called page jink. So we added some really simple tracking there too. We set a timeout for 300 milliseconds, and then we fire a little request to our metrics backend and record the time between those requests, between those requests. If it's 300 milliseconds like clockwork, we know we have a really fast and responsive page. But when we start to see higher numbers, we know that there's something worth looking into there. So we were using Google Analytics. It's also probably a good idea if you're going to try this for real to use a more pro solution. The people who created Circonus really care about understanding metrics deeply. So you get histograms instead of just average numbers. You can spot trends. You can spot correlations. And it's a way for you to pull all of your metrics, both server-side and client-side, all into one place. So trends galore. So after doing all of that, we decided that we would keep around our new tablet experience because the site wasn't the problem. The problem was that we weren't collecting accurate data. So I started off as a person who thought performance was all about database queries and minimizing computational complexity. But now I think it's just one of two ways to improve performance. And it made me much more aware of my biases in how I collect data and how I think about performance. So I'm going to end with a slightly different story about science. Again, no props. It's fine. This is a story about how we've been collecting astronomical data. We've been doing this since the Babylonians. They were keeping observations that they didn't have telescopes, so it was just like naked eye observations about the movements of the sun, the moon, the planets. And given those really primitive tools, they collected some really awesome data. So when Ptolemy came along, he could study those Babylonian records, and he could reason that the solar system looks something like this. The Earth is in the center. The sun is the fourth planet, and the stars kind of sit out in a fixed ether. There are some problems with this view, but it's a huge step in the right direction towards understanding what's actually going on. You all know from history that then we entered an unfortunate period. As Copernicus and Galileo continued to collect evidence, they realized that this model couldn't explain all of the evidence they were seeing. To explain why the planets weren't following a completely circular path, the geocentrist, at the time that was anyone who was a good Catholic or just didn't want to meet the Inquisition, had to concoct caveats upon caveats to explain, to hold on to geocentrism. They would say that there were nested orbits that the planets were following. And when your evidence didn't fit, they would add more orbits onto these circular orbits. So we had a societal bias for or commitment to this model that couldn't be defended with our evidence. It was based on religious ideals. It said that humans are important, so we must literally be the center of the universe. Eventually, we overcame that, and we adjusted our model of the solar system to be heliocentric. But we still couldn't quite explain all of the evidence because we were also stuck in another bias, a bias that originated with Aristotle. He said that circular motion is the motion of the heavens, so whatever paths the planets take, it must be circular. So this is actually closer to what's going on. When Kepler came along and showed that, and hypothesized that the planets were moving in ellipses, he met with really heavy resistance because it didn't meet our expectations for what the data should say. And I see parallels here with how we generally approach performance. Our beliefs about what is slow in our app tend to come not from measurements, but from our own biases. And to some extent, that's unavoidable. But to the extent that it is avoidable, we have to fight it. We used to think that we had good evidence for server performance being the most important. Now the evidence says that 75 to 90% of the page load time is spent on the front end, So in order to do our craft well, we need to adjust our beliefs and kind of adjust our skill sets. We need to remember that there are two equally good reasons for caring about performance: to make sure your site is reliable and to make sure it feels fast for users. And if you're interested in your site being fast for users, that's a lot of yak shaving right now. It'll be some home rolling of your own tools, but it will make some happy users. So thanks to everyone who worked on this stuff with me and whose graphics I used in the presentation. And thanks to all of you for coming to my talk.